Hello, everybody. I'm Everton de Oliveira, the Professor Agua, and I'm here to present to you the new book from the Groundwater Project. It is a great book. I had a very good impression reading the book. I helped a little bit. Lots of good authors. It is, frightening to say something to bright people like that. And the book is called Fractures and Faults in Sandstone Shale Mudstone Sequences and Their Impact on Groundwater. For me, it was a great surprise and I learned a lot. I do recommend to all of you to take a look. Nice illustrations. You learn just by watching. And if you read, then you learn for sure. Okay. The book was prepared by Atilla Aydin, and he passed away. Very sorry. So it's in memoriam today. And Atilla was born in a small village in eastern Turkey. He received his BS degree in geological engineering from Istanbul, the Istanbul Technical University, and his master and PhD from Stanford University in California. He taught structural geology for about 10 years at Purdue University in Indiana, in a graduate course titled Faults, Fractures, and Fluid Flow at Stanford University for about 2 decades. Atilla was the co-author and co-director of the Rock Fracture Project and founder and director of the Shale Smear Project at Stanford University. We have many other authors, and I'll be brief on that. We have Sheng Den, he's a geologist from Moscow University, Russia. We have Marco Antonellini. Marco is here today, and he's talking a little bit about himself. He is professor at the Department of Biological, Geological, and Environmental Sciences at the University of Bologna. We have here today as well Ghislain de Justinot. He's Director of Technology and Operations at the Basic Fran Lab, the consultancy branch of the French Institute of Petroleum. Well, he's going to talk a little bit about himself as well. We have Jian Zong. She received her Master's of Science degree in Geoscience and Computer Science from SUNY Stony Brook, and a PhD from Stanford as well. We have also another author, Antonino Chilona. He received a PhD in structural geology and rock mechanics from the University of Camerino, Italy, and a postdoc who worked at Stanford with Atilla. We have Eric Flodin. He holds a degree in geology at Purdue, Indianapolis, and a PhD in Stanford University, and now works in Luanda, Angola. We have Ramil Amadov. He's here with us today. He holds a PhD and master's from Stanford University, also a student from Atilla. And he's currently working from Azerbaijan State Oil Academy. Another author is John Cherry. Do I need to introduce John Cherry? Actually, I don't think so. Just go to our web page and be amazed at his career. We have also Beth Parker. She holds a Natural Science and Engineering Research Council Industrial Chair in Groundwater Contamination. She works at as director of the G360 Institute for Groundwater Research at the University of Guelph. Many, many impressive names here. Welcome, everybody. Please tell me who's going to talk first, the three of you here. Ghislain, probably you're the one to talk
Okay.
most. Go ahead.
Okay. Hello, everybody. So my name is Ghislain de Justinot, and I'm Director of Technology and Operations at Bicipron Lab. It's a consultancy branch of the French Institute of Petroleum. By background, I have a PhD in structural geology from the University of Montpellier in France. And after this PhD, I joined the Rock Fracture Project, working with Atilla as a postdoc for about 3 years. And that's actually why I relate to this book. And actually, because this book is, first of all, about Atilla. I think that's the message we'll say today.
Very good. Marco, please. Your turn.
Hi, everybody. I'm Marco Antonellini. I'm here a professor at the University of Bologna. I've been trained as a structural geologist by Attila, mostly in the field when I was a PhD student at Stanford. But then in my career, I did a lot of hydrology and hydrogeology, so much that today I'm teaching mostly environmental hydrogeology or coastal hydrogeology and subsurface fluid flow and so on. So Attila was a big mentor for me. And actually, he introduced me to the connection between fluid flow in the subsurface and structural geology. So I think he helped me a lot to develop this panoramic view of the problem. And when a few years ago, he contacted me about this project, this book for the groundwater project, he told me, Marco, it's really time that we need to give back something to of what we learned in the past. And I said, okay, that's great, Attila. So go ahead, and we try to help you. So I think it was a very good thing of Attila to think at that time. So that's where the book idea is coming from.
Thank you. Ramil, your turn.
Yeah, I'm Ramil Ahmadov, and I'm currently, one of the hats I wear is the adjunct faculty at University of Houston. So I teach petroleum geology and hydrogeology, and been doing this for quite a few years. So I was also, as everyone else here, a student, and I came to the group as a master's student. And we had a very good interaction with Attila, and he was instrumental in sort of introducing me to different aspects from field work to lab to computations based on the measurements in the field and in the lab. And I do agree with the previous speakers. This is above all a tribute to Attila and sort of the opus magnum, if you will, for all his career and work.
Oh, that's very nice. That's very nice. First of all, again, congratulations for such an interesting book. The book is very good and impressive illustrations. Very impressive. Could you put a word about Attila's work or initiative on this book specifically?
Yeah, sure. Maybe I can jump in, and please feel free to compliment Ramil and Marco. Well, Attila was at the beginning of the book, and I think that the origin was when he met with John and discussed the groundwater project initiative. So at that time, as Marco said, Attila was really willing to contribute to give back. And I think he considered two projects, one for clastic rocks, that resulted in the book we discussed today, another one in carbonates that he didn't get, unfortunately, a chance to conclude. So that was the origin, and then he contacted us to embark on this last journey together. And from let's say, a construction point of view, he put together a draft of the book. There was a plan and the different chapters and items he wanted to discuss. And then he sent us this draft to edit the sections, write the missing sections, and review globally the book for the general sense and the consistency. So that was how it worked between ourselves, and that's how we managed with such a high number of contributors to end up with a book that makes sense, and that I also enjoyed very much reading and rediscovering for some parts.
Since you touched, how do you guys manage such an impressive list of authors in this book? Because it's you have many people, and the book is, it's seamless. You can read, and you cannot tell who wrote what on the book, because it's perfectly adjusted. The text is smooth and easy to read. Please. wants to say? Marco.
Oh, well, I think that probably Attila is, is the first, is the first one to be congratulated for this, and also Ghislaine, because Ghislaine has put together the last revision of this manuscript. So I would give them the benefit of of doing such a good work, and also because I think that all of us, all those that have been involved in this project, share the same terminology, and we approach structures in a way that Attila told us, all of us. That's probably one of the reasons.
Oh, it's very good. It's very good. So what is in your book for hydrogeologists in general? And why fractures and faults matter for groundwater? And why especially on the sediment sequence of the title? Who wants to go? Now it's your turn, Ramil. You can ask help,
Yeah.
I was gonna give a credit to the team and obviously to Attila and Gilan, and sort of elaborate on the previous point that it's amazing how these many different sections and many different aspects came together in a concise text. And in terms of why fractures in sedimentary rocks, I think that was ultimately the passion of Attila, and most of the research has been evolved. I mean, there were some deviations throughout his career when he looked at other things, but the sedimentary rocks and the fractures in sedimentary rocks, and the fact that not a lot of research has been done prior to that in them, is probably triggered his interest. That's the way I see it, at least.
Very good.
Please chime in, folks.
Yeah, I agree with what you just said, Ramil. And in terms of the interest of Attila, actually that's the most interesting context, sedimentary rocks for fractures. And because you have so much variety of structures to expect compared with magmatic metamorphic rocks, for instance, and especially in sandstone shell sequences where you don't only are limited to fractures and faults, but you also have all the deformation bands. And all these elements play a role on fluid flow. And the key question is, what are the components to expect in your context, the structural components, and what is their role? So the book really presents a catalog of all of these different elements, describe their origin, controlling parameters, and possible fluid flow impact. And then you have to, let's say, define what is the assemblage you will get in your case. So it's like an investigation. You know the possible, the crime scene, and you have to find who's guilty. So
yes.
that's.
That's a nice way to put it. I like it. So do I need a strong background in fractures and faults to use this book?
I don't think that you do, because the book explains very well. I hope.
Yeah.
We'll see the kind of fractures that you are expected to find in a siliciclastic sedimentary sequence. So also the terminology, I think, is explained. And I don't think that you really need a specific previous knowledge to be able to grasp what is important to know, either for a hydrogeologist that works in this kind of rocks, or anybody interested in how fluid can be in some way influenced by fractures and faults in this sandstone. And also Attila's playground was the southwest of the United States, where a beautiful exposure of siliciclastic rocks different kinds of porosity. There is a bit of shale, but mostly this beautiful exposure of sandstone. Yeah, there I think he could observe an incredible catalog of
Yes.
these features and relate them to fluid flow. That is, I don't think it is. You need to have a previous knowledge of these features.
Yeah, I agree. I read it. I agree. Well, and actually, you are correct. The illustrations, the fracture and the sandstones are beautifully displayed in the book. It's so easy. You see things, not only that he explains, but you see what is in there. It's very, very impressive. I enjoyed it a lot. So, but for us hydrogeologists, fractures are related to hard rock or, igneous or metamorphic. What are the differences for those rocks that we're used to, the sandstone, the sedimentary sequences?
Well, that's a complex question because there are many answers to this question. First, I would say that there is variety in metamorphic magmatic rocks. Usually you have brittle structures, so you have faults and fractures, breaks in the rocks, and they can introduce very significant permeability because usually you have no rock porosity and permeability. So whatever breaks the rock will give you the permeability. That's the simplest concept. Of course, you have more complex situations, but that's the basis. Sedimentary rocks, it's more complicated because you have already permeability component in the matrix. Could be very high in the cases that illustrate the book. Sometimes it was Darcy permeability, so extremely permeable rocks. And then you have these brittle features, fractures, faults. And in addition to that, you have the bands associated to these initially highly porous rocks. And some of the structures could provide permeability, some could act as conduits, some could prevent from the fluid flow and actually decrease the permeability of the system. And they can occur at the same time in the same area. So most of the time it results in anisotropy that you have to capture. And this anisotropy will also have to be considered again in the global context with the rock itself. So that, to me, that's a big difference with magmatic metamorphic rocks, much more variety and much more complex fluid flow effects because of the interplay between the structures and the rock and their properties, and because some features introduce more permeability and some decrease the permeability.
Interesting, that's true. And well, when you go to a sedimentary rock like that, and you don't see the fractures, these features in outcrops, you tend to assume that it's all homogeneous, right? It's just the porous media that acts it, and then you see all this big difference. And that brings me to the question of you have the potentiometric map of the Santa Susanas in your book. That's very interesting, and it's highly complex, right? To be produced. Tell us a bit more about, what kind of work we need to produce such an interpretation. Because when we go to the field, being hydrogeologists, it's very hard to produce such a detailed map. And we see that the fractures played a huge role in that map. Can you tell us a little bit about that presentation? Because it's very, for me, it was, very instructive. You take a look at that. Look, you have to be very careful when you're dealing with these features in the field. Please.
So who wants to comment on that?
Well, person to comment on this would be Antonino.
Yes.
Because he is the one who studied that basin. But as far as I remember from his paper, that is already from 2015, he integrated the different methodologies. So he was able to have an incredible number of well data for the potentiometric level, so he could reconstruct a potentiometric surface. He had the availability of some good outcrops where he was able to do transects across this shear zone, basically a complex fault, because it, as far as I remember from Anthony, it was a fault zone which was fractured, but there was also shale smear, which to fracture it introduce another process, which is the shale smear, that actually can create a compartment within a reservoir. And he had also, if I remember correctly, a borehole across the fault zone. So he was able to integrate well data with borehole data, with a core, and outcrop data. So in that way, he was able to create such a detailed map of, and was able also to draw some important conclusion. One, that the fault was probably a barrier to flow, and also that, if I remember correctly, always that in the steps that were thought to be like potential ways for the flow to go through, indeed there was not. There was also a barrier. That what I think was an interesting study. I don't know, Ghislaine, if you know about
that's yeah, you summarized it quite well, Marco. It's one of the best examples we have seen, actually, because it combines 350 wells, something like this, with measurements at different levels, different units. You have these nice outcrops. You have also some geophysical measurements. So you know what are the structures. The aquifer on its recharge was assessed, I mean, well defined. And it's because of this analysis in the wells, measurements of the fluid flow through time, and especially targeting contaminants, that actually we could relate the distribution and migration of the contaminants with the barrier effect of this fault that Marco described. Actually, the contaminants were deflected along the fault and formed an elongated plume parallel to the fault and could not cross this major fault. So that's a beautiful case, but to build a case like this, you need an underground lab with years and years of measurements, good structural geologists with the concepts, and we need the proof made by the measurements repeated through time. So that's a world-class example, I would say.
Well, but it's highly instructive, because you can learn to think better with all this information. I love it. It's quite interesting. I'll like you. I'll put some words here. I'd like you to make your final considerations, but I have a final consideration here for any potential reader of the book. When you see a title like that, it might be frightening. Oh, Jesus, I'm gonna see all this, difficult stuff about, and it is not. The book, it is so well put together. It is an interesting reading. It is compelling, and you learn on an easy way. That's my impression. I don't know about yours. You're the authors. You had objectives, but I'm a reader, and I really enjoy that. You have the nice presentation, this introduction. and then you go through details and with pictures, and then you have the final, the interpretation of this aquifer that is quite impressive. It's very good to learn. So if you see the title, if you're watching this interview, don't be scared. Just go take a look, and it's free. You just download and take a look, and I'm pretty sure you learn a lot. Please make your final statement, guys.
Yeah, I think the reader would truly enjoy reading that, irrespective of the level of the knowledge, as you mentioned in the beginning, whether or not you have an extensive knowledge of the faults or fractures or the other aspect, which is the fluid flow. And even if you don't, the examples and the coherence and the flow will actually bring everything together. So really hope that the reader is going to enjoy it.
Yeah, I did.
Yeah, and again, the notion behind the book and in Attila's mind was to educate and create awareness in the minds of people that don't know well the subject. So we have all these illustrations, and it might seem complicated, as you mentioned, but you can break it down to simple elements. So all of the features are described and the relevancy is discussed. And then after that, all you have to do, and it's a tricky part, I agree, but is to combine these elements. And my advice, I mean, I consider this is a reference knowledge base that could be used. I mean, you can use it to produce models of an underground reservoir, aquifer storage site. And you can always start with a simple combination of elements and introduce complexity if you don't get a match, And this book allows you to do that because you have the elements separated and well described, or at least we think they're well described. And actually, that's the kind of work we do on a daily basis when building fracture models. You start with simple combinations, and then you introduce complexity to explain complex physical behaviors.
Very good. Marco.
Okay, but for me, I think that the book is for anybody that is interested in hydrogeology. And one thinks, well, sandstone is a beautiful aquifer. It's a very nice aquifer. And one thinks sandstone can be so homogeneous. But if you read this book, you will find out, as you were mentioning also, that also this aquifer, these bodies of rock, this sandstone might be very, very complicated and heterogeneous inside because of the structural components. And that, I think, would be the message of this book.
Yeah, and I totally agree. Thank you, guys. Well, it gives you ideas because then you go to the field and something, if you expect homogeneity and then something wrong happens, at least you have ways to think and to look for the problem with this book. Because, it's very common to expect that, sandstone is homogeneous, and it's not. We have here lots of sandstones in Brazil. The Guarani aquifer, a huge structure of sandstone, and we do have fractures there. It's very interesting, and I love your book. So, guys, thank you very much for a job well done, and we'll make an effort to this book to become a success as it deserves. Congratulations, and let's work for people to learn more about the fractures. Thank you very much.
Thank you.
Thank you very much.
Thank you. Thank you.